We're going back to RLC circuits, and what we want to do now is basically maximize the current that's going to go through the circuit. And the way that we do that is by reducing the impedance. If impedance goes up, the current will go down. If the impedance goes down, the current will go up. So we want to get Z as small as we possibly can. The idea here is that if you look at the impedance formula, VR squared, that will always stay the same because a resistor, it does not matter what frequency we use, the resistor is just going to be constant. So what we want to do is we want XL minus XC to be the least. And basically, because we're subtracting, that would happen if they were equal, because they would cancel out, and that would be a resonant frequency, so that practically the only thing that would be reducing current is the resistor, because this would be 0. So if we work this out, we can figure out a formula to find the best frequency. Now I'm going to add this to the other side. Now I'm going to multiply f over and then divide both sides by 2 pi l. So this is going to be f squared 4 pi squared CL. Okay, and then if we square root, we're going to end with 1 over 2 pi the square root of CL. So if we know the capacitor and the inductor, we can figure out what frequency we should set our voltage to be at so that we would have the most current flowing through. So for an example, let's say that we had a household circuit. So this is 60 Hertz. And we also know that we have a capacitor with 15 microfarads, and then we also have an inductor, but we don't know what the inductor should be at. So basically we want to know, to get the most current, what kind of inductor should we use? Well, we're going to use this equation and plug in what we know. This would be 60 equals 1 all over 2 pi square root, and inside the square root we will put 15 times 10 to the negative 6 times L. That's what we need to figure out. Alright, to make life easier, this part right here I'm going to highlight. I'm going to swap with the 60. This is a legal move because, like, if you have 12 equals 24 divided by 2, this you could swap with that, and it would be the same problem. So 24 over 12 equals 2. So that's a little algebra trick here. The square root and then this would be 1 all over, now it would be 2 pi times 60. So I'm going to write 120 pi here. Alright, the next step here is to square both sides. Now this is going to be 120 pi squared. And then I'm going to have to divide both sides by this. So L is going to be 1 all over times the capacitance. Now working all that out, we would have 0.469 henries. Now that's awfully big for an inductor, but maybe you string a bunch of them together to get that. And I'm not claiming this is a realistic circuit we would ever want to build, but it is possible to toy around with this equation and make sure that you have the frequency, the resonance frequency you would like.